head-mounted display create a highly immersive experience, however, which limit VR users' awareness of external users that co-located in the same physical environment. In our work, we designed a wearable gesture-based interface for the external users to enhance their asymmetric interaction capability. In the system, the external user wears a Vive tracker that attached to his head to locate the relative position in the virtual scenario. An accompanying virtual camera projects the external user's perspective onto the physical environment. We use leap motion that tied around the external user's waist to interact with the VR user in real time. We encourage the external users to become a part of the shared VR experience and enable them to interact and explore the environment with the VR users in a collaborative way. Our system allows external users to explore the virtual scenario spatially and generate asymmetric communication with VR users in two different modes. 1. Object transition and 2. Collaborative game. In Scenario 1, the selection and transition of virtual objects are important interactive behaviors in VR collaboration. In object transition scenario, both VR and external users should pick up specific color notes and throw them to each other. We provided object interaction through generating interactive rays for the external user, which includes 3 hand gestures: click, summon, and pinch. The external user can select the blue note through a generated blue ray by pinching with 5 fingers, then he or she can summon the note ball by flexing the 4 fingers, and placed into the square to throw at the VR user by pinching hand. The VR user can place the purple note into the square and pass it back to the external user as feedback. The collaborative game is a typical interactive form in asymmetric VR. Therefore, we designed an asymmetric cooperative game. For the gesture-based interaction, we designed gestures, slide, OK, and confirm. The external user looks for the location of the puzzles and send gestures to inform the VR user where the puzzles are. VR user can teleport and pick up the puzzles in virtual scenario. The external user controls the range and brightness of the searchlight by pinching the index finger and thumb from the right hand, and send an OK gesture to inform the VR user that the puzzle has been found. The VR user could follow the light cues and use controller to teleport and pick up the puzzle, then press the trigger button as confirmation. The external user would transfer the puzzle into the target position by presenting the thumbs up gesture. We conducted a hybrid user study with 20 participants to compare the wearable gesture-based interaction and the traditional controller-based interaction, to investigate the effects on VR immersion, social presence, and collaborative efficiency for external users. A primary study showed that our wearable gesture-based interface received more positive feedback on the sense of VR immersion, social presence, and collaborative efficiency. The external user had a stronger sense of immersion and social experience, due to the freedom of hand gestures and body perception. It could help both users perceive each other's interactions more clearly and give better feedback for collaboration. Meanwhile, our system still needs to be further improved in terms of learning cost and gesture design accuracy. The participants also provided additional suggestions for future implementation: 1. Comparing gestures-based interaction and controller-based interaction in different collaborative scenarios; 2. Designing more natural and cognitive gesture-based interaction.